NASA says its Explorer 1 test, the most far-off human-made object in the universe, is sending usable data to Earth again. After traveling almost 14 billion miles from Earth, Explorer 1 has made a discovery so significant that it has changed the direction of its mission, turning around towards our planet. But what precisely might this revelation be? Could it be proof of extraterrestrial life, an invaluable anomaly, or something even more unfathomable? In this gripping investigation, we'll disclose these stunning discoveries as Explorer 1 has recently made an alarming revelation that prompted its sudden turn back toward Earth. The Explorer twin tests may have never left Earth if certain heavenly events hadn't coincided. About 60 years ago, the 4 biggest planets in our solar system were slowly aligning in a way that last occurred during Thomas Jefferson's administration in the mid-19th century. This intriguing planetary arrangement went largely unnoticed at first. The first individual to recognize its importance was Gary Flandreau, a dual student in flight at the California Institute of Technology in 1965. At that time, space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with figuring out the most effective method for sending a space probe to Jupiter or significantly further away to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these giant planets and made a captivating revelation. In the late 1970s and mid-1980s, all 4 planets would align in such a way that they could be visited in a single mission. This arrangement meant that a spacecraft would be able to utilize the gravitational pull of each planet to slingshot itself to the next, essentially reducing travel time. Flandreau determined that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment only happened once every 176 years. To exploit this unique opportunity, a spacecraft would have to be launched by the mid-1970s. NASA seized this once-in-a-blue-moon alignment and built 2 spacecraft to make the journey, Explorer 1 and Explorer 2. Their launch on September 5, 1977, marked something truly extraordinary at Cape Canaveral in Florida. Explorer 1 embarked on its awe-inspiring journey into space, propelled by a powerful rocket known as Titan 3E, only 15 days after Explorer 2 was launched on August 20, 1977. Explorer 1 joined the cosmic adventure, starting its journey into the vast universe by following a more direct route. Their primary mission was to investigate the massive gas giants in our solar system, like Jupiter and Saturn, along with their various moons. However, these brave space explorers exceeded all expectations. They ventured far beyond, pushing the limits of exploration, traveling farther and longer than any other spacecraft in history. They broke various records on their inspiring odyssey, having traveled past anything made by humans before, even venturing into a region known as interstellar space, a completely strange domain within our system. These exploring spacecraft, Explorer 1 and Explorer 2, are now more than 12 billion miles from us. Despite their immense distance, they continue to amaze researchers with the remarkable discoveries they make out there. Most recently, they have made a revelation so startling that it has taken everyone by surprise. The Explorer twin probes have achieved several truly exceptional accomplishments. Years ago, they investigated the moons of Jupiter and Saturn, surprising researchers who initially believed them to be dull and heavily cratered like our moon. These moons turned out to be dynamic hubs of activity. Explorer 2 made history by becoming the first of the twins to swing by Uranus in 1986, and just 3 years later, it dashed past Neptune, an accomplishment unmatched by any other spacecraft. As these spacecraft continue their incredible journey, NASA employed clever strategies to ensure they remain functional. They have deactivated non-essential parts like spare instruments and radiators to conserve power, aiming to keep the spacecraft operating until at least 2030. For the dedicated scientists and engineers who have been part of this remarkable journey from its inception, it's a bittersweet mix of emotions. Their hard work has paid off, and just when they thought the Explorer missions were nearing their end, a shocking discovery emerged from the depths of space. Explorer 1's revelation involved data transmission and discovery at the beginning of their incredible journey. Years ago, the Explorer spacecraft stunned analysts by providing the first up-close views of the moons of Jupiter and Saturn. These moons, which astronomers had assumed to be dull and heavily scarred like our own moon, turned out to be dynamic worlds. Explorer 1 reached Jupiter in spring 1979, only 546 days after its launch. Explorer 2, following a slightly different path, arrived in July of that same year. Both spacecraft were equipped with VidCon cameras that used filters to capture full-color images. Interestingly, they were designed to be incredibly stable, rotating through space at a rate more than 60 times slower than the hour hand of a clock, ensuring that the images they captured were clear and sharp. During their mission, the explorers took over 33,000 photos of Jupiter and its moons, each revealing new and captivating details. For example, Europa, one of Jupiter's 53 named moons, was found to have a cracked icy shell estimated to be over 60 miles thick. As the spacecraft departed from the Jupiter system, they received a farewell boost in speed of 35,700 miles per hour from a gravitational slingshot, a pivotal move that helped push them towards interstellar space. At Saturn, the explorers went their separate ways. Explorer 1 passed through Saturn's majestic rings, enduring countless impacts from small dust particles before flying by Titan, a moon shrouded in an orange fog and traveling north out of the plane of the planets. Explorer 2 continued its solo journey, arriving at Uranus and Neptune in 1986. During its visit to Uranus, Explorer 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Explorer 2's accomplishments were overshadowed by tragedy. Only 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after launch, claiming the lives of all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Explorer 2 flew around 2,800 miles over Neptune's striking bluish methane sky, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest spots in our vast neighborhood, with surface temperatures plummeting to a staggering minus 235 degrees Celsius. The moon's icy volcanoes were another astounding find, launching nitrogen gas and fine particles up to 5 miles into its atmosphere. After Explorer 2's mesmerizing images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, cosmologist Carl Sagan, a member of the mission's imaging team, intervened. Despite the grand tour still concluding, NASA extended the mission in hopes that the spacecraft would venture into interstellar space, renaming it the Voyager interstellar mission. The probes were set to continue their journey into the unknown. Sagan convinced NASA to allow Explorer 1 to take one last series of pictures. On Valentine's Day in 1990, the spacecraft turned its camera back towards the inner solar system and snapped 60 final shots. One of these pictures, famously referred to by Carl Sagan as the pale blue dot, captured Earth from a stunning distance of 3.8 billion miles. In the image, Earth appears as a tiny speck, barely discernible against the vastness of space, illuminated by a faint beam of sunlight bouncing off the camera's optics. We've learned so much about the planets and moons in our solar system. It's exciting to see how unique they are, even those that are the farthest away. The Voyager journey past the heliosphere in August 2012 marked an incredible achievement by venturing beyond the heliosphere, a vast region of charged particles produced by the Sun. Voyager 1's extraordinary feat became widely recognized the following year when a study was published in the journal Science. It's historic to share Voyager discoveries. The spacecraft's plasma wave instrument detected a powerful solar emission between April 9th and May 22, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found just inside the heliosphere. At first glance, it may seem astonishing that the electron density is greater in interstellar space than near the Sun. However, scientists explained that the electron density at the heliosphere's edge is significantly lower than at Earth's surface. Analyzing Voyager 1's data, scientists pinpointed the official flight date as August 25, 2012. This determination did not rely solely on electron movements, but also on measurements of charged solar particles collected by the spacecraft on that momentous day. Coincidentally, this was also the day that the famed Apollo 11 astronaut Neil Armstrong passed away. On this significant date, Voyager 1 detected a remarkable 1,000-fold decrease in solar particles and a 9% increase in cosmic rays originating from outside the solar system. These findings shed light on the dynamic and ever-changing nature of our cosmic neighborhood, showcasing the vastness and complexity of space exploration. Voyager 1 reached an incredible distance of 11.25 billion miles from the Sun, which is around 121 astronomical units. At this point, NASA's Planetary Science Division was tirelessly investigating the solar system using a variety of techniques, including flybys, orbiting, landing, and returning samples. The Voyager missions served as trailblazers and modelers of this approach, laying the groundwork for future exploration. The Voyager spacecraft played a crucial role in studying the universe and shaping our research priorities. By conducting flybys, these missions greatly enhanced the success of planetary science. The concept of gravity assist, which involves using the mass of a planet or another celestial object to change the speed and trajectory of a spacecraft, was fundamental to Voyager's successful exploration of the outer planets. Researchers and astronomers, in their quest to understand gravity assists, made an astonishing discovery about the vastness of space. In addition to relying on gravity assist for navigation, the Voyager missions had another critical component: the Deep Space Network, DSN. This component functions like a huge telephone line that keeps us connected with our brave Voyager probes as they wander into the unknown. So, what exactly is the Deep Space Network? It may not be as conspicuous as a spaceship, but it's incredibly vital. The DSN resembles a vast web of radio antennas spread across the globe, from California to Spain to Australia. These giant dishes, some as wide as 70 meters, serve as space amplifiers, enabling us to communicate with spacecraft that are far out there. The DSN's role in the Voyager missions is crucial. The Voyager probes, equipped with cameras and sensors, are our eyes and ears in space. To make sense of the data they send back and to provide them with instructions, we needed a robust communication system, and that's where the DSN plays a vital role. When Voyager 1, traveling to the outer reaches of our solar system, sends a message back to Earth, it's a weak signal racing incredibly fast through space. When it arrives on Earth, it's barely a whisper. But fear not, the DSN's epic radio antennas are capable of capturing that weak signal, locking onto Voyager's whisper and transforming it into usable data for scientists. The Deep Space Network isn't just about receiving signals. It also sends commands. Missions like Voyager are dynamic, requiring scientists and engineers to adjust plans or carefully guide the spacecraft. These commands are sent through the DSN, traveling through space to reach Voyager. It's like having a two-way conversation between Earth and the most distant human-made objects in space. One remarkable aspect of the DSN is its constant operation, day in and day out, always listening for those distant signals. It's more than just a collection of antennas. It's our indispensable space connection. The DSN keeps the stories of the Voyager missions alive, even as the spacecraft venture far beyond our solar system, exploring the unfamiliar regions of interstellar space. The long journeys of the Voyager spacecraft have been filled with unexpected challenges. Voyager 1, in particular, is equipped with 3 onboard computers, including a flight data system responsible for gathering information from the spacecraft's scientific instruments. This data is then sent to mission control on Earth in binary code, which is a series of ones and zeros. Recently, however, Voyager 1's flight data system seems to be stuck in a loop, repeatedly sending the same pattern of ones and zeros back to Earth. This issue was first observed on November 14th, when the spacecraft's communications unit began acting erratically. While Voyager 1 can still receive and execute commands from mission control, this problem means that no new scientific or engineering data is being transmitted back to Earth. NASA engineers have attempted to restart the flight data system, but so far no usable data has been received. They are now trying to identify the underlying cause of the issue before deciding on the next steps to fix it. This process could take several weeks. Interestingly, this is not the first time Voyager 1 has experienced issues with its flight data system. A similar problem occurred in 1981. However, the current issue does not seem to be related to any other malfunctions the spacecraft has encountered recently. As the Voyager probes face new challenges, the mission team is relying on manuals written many years ago for guidance. These manuals, while comprehensive, could not have anticipated all the difficulties the spacecraft would face as they continued their journey through the universe. The team is taking a cautious approach, carefully considering every possible implication before sending further commands to Voyager 1 to ensure that its actions are not unexpectedly affected. Voyager 1 is located so incredibly far away that it takes an astounding 22.5 hours for signals to travel from Earth to the spacecraft. Additionally, it requires an extra 45 hours for the team to receive a response. Imagine waiting nearly 2 days just to hear back from a spacecraft. As the Voyager twins continue their epic journey through space, the team has had to make some tough decisions to keep them going. They've turned off several instruments on these aging probes to save power and extend their missions. Along the way, both spacecraft have encountered unexpected problems, such as a 7-month period in 2020 when Voyager 2 could not communicate with Earth. In a stroke of luck, the team managed to restore communication in August using a clever method that realigned the spacecraft's antenna. While the team is hopeful about restoring the normal flow of data from Voyager 1, the true value of these missions lies in their longevity. Researchers are eager to study how particles and magnetic fields change as the probes venture farther from the heliosphere. However, this crucial data set will be incomplete if Voyager 1 can't send information back. The team has also been creative in finding ways to extend the power supply on both spacecraft. Despite the challenges, the Voyager missions have far exceeded their initial expectations, outliving any other spacecraft in history. So while the engineers are working tirelessly to keep them operational, they also know that more challenges may lie ahead. Regardless of their diminishing power, the journeys of the spacecraft are far from over.